A removable discontinuity happens if you had a function that you could factor and two of the factors are going to cancel out. So let's say we had a function, we factored it, it looks like this in the numerator and then this in the denominator. These can cancel out. X equals 4 is the removable discontinuity. Because even though we've canceled out the x minus 4 up top and x minus 4 down bottom, the original function definition was such that 4 would cause a hole. You can't plug in 4 or else you would have had a divide by 0 error in the original function. Okay, so let's look for ones where we could have a removable discontinuity. F of t equals t to the negative first. So this is 1 over t plus 1, in other words. There's no factoring we can do to a numerator denominator here, right? Even if you get common denominators, you're not going to make something cancel out up top and something cancel out on bottom. So this does not have removable discontinuity. And at t equals 0, it's undefined, but it's an asymptote. It's not that whole. Okay. Here, a removable discontinuity looks like this on a graph. Okay. So it doesn't make a hole, it makes an asymptote. It's different than a removable discontinuity. This function here, you can't really factor the top and the bottom, right? Because x squared plus 1, there's no way to factor the denominator. So there's actually there's no problem with any number for x. All real numbers are possible for this function. This function, if you factor the top and the bottom, you can only factor the bottom. There's a removable discontinuity because the x's cancel out. So x equals 0 would be a removable discontinuity there. Tangent x has asymptotes, but no removable discontinuity. You can rewrite tangent as sine over cosine. That way you can start looking for those divide by 0 errors. So tangent 2x is sine 2x over cosine 2x. And cosine is 0 at pi over 2. And at negative pi over 2 or 3 pi over 2, any of those places that would cause cosine to be 0. So we can make cosine be 0, but those are going to be vertical asymptotes. It's not removable discontinuities because it's not canceling out with something up top. Here, you could certainly find an x that would make this have a divide by 0 error, but it's not a removable discontinuity for the same reason as this one up here, because you're not canceling out after factoring. So right now, all we have is this one as a removable discontinuity. Down here, let's try to factor the bottom. Let's see, two numbers that multiply to be 6, but have to be 5. So how about t plus 3, t plus 2? I factor the bottom. The top and the bottom can cancel out, so t equals negative 3 would be a removable discontinuity here.